Welcome to Festool TV. My name is Frank. In this video, we'll be discussing the OF1010 and the application of template routing. For template routing, I'll need these copying rings, which are available in different sizes and for different applications. For this kind of copying ring, I'll also need a template, as the copying ring will be sensing the template. This will allow me to machine different contours. Here's the Festool routing template. We've already discussed this template in previous episodes. In this video, I'd like to show you how you can use a self-contoured template to route individual grooves. For example, for routing this small door, which is a type of filling. I'm now going to demonstrate how it works and which accessories I'll use. Firstly, I'll take the copying ring and the corresponding cutter. Of course, these need to be compatible with each other. It should be possible for the cutter to move inside the copying ring at a later stage, but it mustn't be too large, as that would destroy the copying ring. I'll then insert the copying ring into my router where there's a filling ring fitted. The copying ring will be inserted in place of the filling ring. To do this, I'll first unscrew these two screws. These screws here are countersunk screws, and they aren't used with the copying ring. We've got special panhead screws for the copying ring, and I'll show you how to use these later on. To position the copying ring exactly at the center, I need a centering mandrel. If the copying ring is not screwed in exactly at the center, the machine may rotate when template routing, and the distance may no longer be right for routing. You therefore need to ensure that the copying ring is fitted exactly at the center. I'll push this centering mandrel into the holder where the cutter will be used. We'll lock everything using the spindle top and tighten it by hand. I'll loosen it all again. The copying ring is now positioned on the centering mandrel, and I can now precisely align the copying ring. I now know that the copying ring is positioned exactly at the center. I'll now screw down the copying ring using the panhead screws included in the scope of delivery. I'll tighten the screws. The copying ring has now been installed. I'll loosen it all again, which involves removing the centering mandrel. I need to install the relevant cutter in place of the centering mandrel. I've chosen a profile cutter. Obviously, there are no limits to your creativity. You can use any cutter which fits into the hole of the copying ring. I'll tighten the spindle lock, followed by the collet's union nut. The cutter and copying ring have now been fitted. Now I'll just need to adjust the depth. To do this, I'll proceed as follows. I'll loosen the black clamping screw here. I'll push the router down until it comes into contact with my workpiece. I'll then set the stop to the smallest pin on the turret stop. There's quite a lot of stops. At the side, I'll push this stop up above the mark and set it to 9 mm. Why set it to 9 mm? You may need to produce a model piece beforehand in order to determine the precise depth. The deeper you route into the material, the more the profile shape of the profile cutter will change. But as mentioned earlier, there are no limits to your creativity. The machine has now been set up. We just need to connect the power supply and the extraction system. We're ready to go. We've now finished routing everything. As you can see, the extractor didn't manage to extract all of the chips. This is because there's a lot of elements which aren't enclosed, but it's still better to work with an extraction system than without one. Let's take a look at the result. As you can see, we've got a wonderful cutout. Of course, you can then finish the workpiece using the right abrasive paper. We also have the option of profiling at the side. I hope you enjoyed this video about template routing with the OF1010 router and the corresponding copying rings. I look forward to seeing you again. I'm Frank. Thanks for watching. See you next time.